Today we are going to study about laws of logarithms. Last class I told you that logarithms are used to do difficult calculations. Now they are done with the help of these laws. So the first law, which is also called as a product law, that says log of m into n is equal to log m plus log n. Now over here, the base can be anything. Say the base is a, m upon n. Then this will be log m minus log n. Product law. This is quotient law. The third one is called as a power law. Log of m raised to n to the base a is n times log m. Log of 1 to the base a is always 0. Okay, we have seen this. This is a raised to 0 will be 1. That is the reason why. Then there is a common logarithm, the one which is used for calculation, in that the base is 10. Okay, so therefore, if there is no base given, log 10 to the base 10, so that will be 1. Log a to the base a is 1. Okay, so that also is another rule. Now log 100 to the base 10, this is 2. Now the working I'm showing you, because 100 can be written as 10 squared. So that is 2 times log 10 to the base 10. That is 2 times 1, that is 2. So if you have 1000, that will be 3. Because 1000 is 10 cubed. So that is 3 times log 10 to the base 10. That is 3 times 1, that is 3. Now what if you have numbers less than 10? Say 0.1. Then this will be 0.1 is 10 raised to minus 1. So that is minus 1 times log 10 to the base 10. Minus 1 times 1, that is minus 1. Exercise 8a, log of x minus 1 plus log of x plus 1 is equal to log 1 to the base 2. Okay, so in this particular case, what I can do is, if I apply this, I solve this part. Log of 1 to the base 2, if I take it as some k, then I know that 1 will be equal to 2 raised to k. Now, since 2 raised to 0 will be 1, therefore I can take k is 0. So here I can take this as 0. So therefore, I will get on the left hand side, I have log of x minus 1 plus log of x plus 1 equal to 0. Okay, so the product rule says that log of a plus log of b is log of a into b. So if that rule is applied to the left hand side, I get log of x minus 1 into x plus 1 is 0. So therefore we get log of x squared minus 1 squared is 0. Now we have seen another rule. That rule said that log of 1 to the base a is 0. That means if log of some number is 0, that means that has to be 1. So therefore I can say that x squared minus 1 is equal to 1. Therefore I get x squared is equal to 2. That is negative 1 goes over there. And that will make it 1 plus 1, that is 2. So x will be equal to plus minus root of 2. If nothing is given, then we assume the base to be 10. So this is logarithm, which is written as exponential form, will be 10 raised to 2, will be x squared minus 21. Now 10 squared will make it 100. And here we get x squared minus 21. So that is transferred on the other side. So we get x squared as 121. X is equal to plus minus 11. Express in terms of log 2 and log 3. So first thing you have log of 36. Okay, so what we do here is find the prime factors of this. Log of 36 is written as 2 squared into 3 squared. Log of AB is log A plus log B. Therefore, this is log of 2 squared plus log of 3 squared. Then we use the law of power, that is A raised to M is M times log A. Therefore, this is 2 log 2 plus 2 log 3. That's what they want us to do. Express in terms of log 2 and log 3. Log of 4.5. So in this case, I'm going to make it as log of 9 by 2. So then I'm using this law of quotient, that is log of A by B is log A minus log B. So this will be log 9 minus log 2, which is 3 squared, which will be written as 2 times log 3 minus log 2. So this is what we have succeeded in writing in terms of log 2 and log 3. We use the quotient rule here. So because there is a negative sign, so I write log of 26 upon 51 divide by 91 upon 119. This is log 26 upon 51. The division turns into multiplication. (51) goes in which number? 17. That is 3s are, goes 7s are. So this 7 and 7 also are getting cancelled. So this is log 2 upon 3, which can be further written as log 2 minus log 3. Log 75 over 16. Log 75 upon 16 minus the 2 goes, that is the power law. So that will be 25 upon 81 plus log of 32 upon 243. Now, when you write them together, this is 75 and this is 16. So you remember the negative is going to get divided. So I can write it as 81 upon 25. The addition is going to get multiplied. So that is 32 upon 243. So now the cancellation, 25 3s are, 16 2s are, and 81 3s are. This 3 and this 3 will get cancelled. So we are left with only log 2. That's the answer. Part 1. So you have 2 log x minus log y equal to 1. Now, free from logarithm means there should be no log written in the expression. So how can we do that? So you need to simplify this. First of all, this is 2. So therefore, this is log x squared. Now there is a subtraction, so that will turn into division. That is log x squared upon y is 1. Now one thing we know, if there is nothing written here as a base, we consider that as 10. So now this thing has to be written as an exponential. So 10 raised to 1 is x squared upon y. So therefore x squared is 10y. So this is what they say, free from logarithm. So there is no log in this expression. So this is log x squared log y cube equal to log a. There is a plus sign, so there will be multiplication. So log x squared y cube equal to log a. So when you have log of an expression equal to log of another expression, so obviously these two must be equal. So what we do is, to remove log, we can't just cancel like this. Okay, we have to say taking anti-logarithm on both sides. So that means you remove log. So x squared y cube equal to a. So this is log of x raised to a, log of y raised to b is log of 3 squared. There is a minus sign, so that will be division. X raised to a, y raised to b, and this is log 9. Again, taking anti-log, you have x raised to a, y raised to b equal to 9. So we have written it free of logarithm. The next question expect us to evaluate is to find an answer to this without using tables. Now, what is the meaning of without using tables? So I'll show you what are log tables. Last class, I told you that Napier formulated this method of logarithm to do complex calculation. So to do this calculation, they use these tables. So over here, you can see that it is written logarithmic base 10. So these are log tables. Now then, if you see, it says anti-log. So these are the tables which they are asking us not to use that table and still calculate the value. Okay, so how do we do that? So in this particular case, here, this is log 5, this is log of 8, and this will be log of 4 because this 2 goes over there. It will become 2 raised to 2, that is 4. Now, in this particular case, this is a addition, so that will turn into multiplication. This is subtraction, so that will turn into division. So 4 ones are, 4 twos are. So you will get log 10. And I told you when nothing is given, you assume the base to be 10. So log 10 to the base 10, the answer is 1. Because the law says that log a to the base a will be 1. This is a addition, so that goes into multiplication. This is also an addition, so that will be multiplication. Before that, this is 3 raised to 2, so that will become 9. And this is a subtraction, so that will go into division. 9 ones are, 9 twos are, 2 ones are, 2 fours are. So this will be log 4 into 25. That is log 100. Now we have studied that log 100 is 2. So this is log 4. 125 raised to 1/3. And this is 1/5. Log 5, log 2. Now this is addition, so that changes to multiplication. This is subtraction, so that changes to division. 2 ones are, 2 twos are. So this is log of 10. So the answer will be 1. Log 10 to the base 10, that will be 1. Here we want to find the value of x. So we can keep x on one side and take these terms on the other side. So the negative log 48 will become plus log 48. This is 3, so that will be 2 raised to 3, that will be 8. This will be log of 125 raised to 1/3, and this is log 3. So now what we do is this is 48, this is negative, so there will be a division upon it. This is plus, so there will be a multiplication, and this is again minus, so that will be a division here. So 8 6s are, 3 2s are. So this is log of 2 into 5. That is log 10. Now log 10 we know is 1. So the value of x is 1. In this we are using the product rule. So log a plus b is log a into b. This is equal to log 5. Now you have log of an expression equal to log of the other expression. So therefore we take anti-log. So we get rid of the log, and here you have x squared minus 4, that is equal to 5. So you get x squared as 9, negative 4 goes on the other side. So we have x as plus minus 3.